Okay guys, so today we're going to talk about rigging, and the rigging that we're going to cover is both the mechanical side of things as well as organic rigging and skinning. So I'm going to try and break it up into two halves and then see how much we can cover within this lesson. The first lesson we're going to break it down to its core principles. Let me just close all of this unnecessary textures, create a new canvas, and I'm going to fill that in with white. And I'm going to set my color to the background, to black. There we go. Right, so if I were to fancy brush stroke, there we go, that's better. Yeah, there we go. I'm going to try and break up the first lesson into talking about the most basic concepts, and then in the second half talk about actual bones, rigging, using controllers, and then skinning. Right, so let's write down some key things that I want you guys to keep in mind. And the first thing is going to be the following. We're going to focus on pivots, right? That's very, very important. And that will essentially allow us to control the object's rotation. So pivot is going to be one of the key things that we're going to focus on. The second thing is we need to essentially know which part of a body part, or let's say it's an arm with a cylinder like that, right? And that how that will bend. Let's make another cylinder for the forearm, and essentially the pivot is going to be around about there, and this will rotate around that circular pivot point from there. Now, this will only rotate successfully if these two are linked to each other, like in a typical human biped kind of system, where the forearm would be attached to the upper arm, and the upper arm would be attached to the chest. So whenever the chest moves, the upper arm moves, so does the forearm. So by knowing where we parent these things in a certain hierarchy, we allow a lot more accessibility in terms of movement, and it also makes the process of understanding how the object will be bending and deforming a lot more easier as well. So parenting is quite important. That's going to be the second thing that we need to address. And then the last thing in terms of that, let's just cut this, move it down, move this across maybe, and easy like that. Fill that with white again, deselect, and let's write down the last thing, and that's going to be limitations. We're going to limit the movement, the rotation, and well, you could technically do the scale as well if you're really going to be scaling the arms or the body parts for that matter. But you're just setting up certain limitations so that you don't have body parts going through each other. Technically, if you think about it, geometry is just geometry. It doesn't have a physical collision detection thing like we have in real life. So we have to essentially provide certain frameworks or certain structures that essentially say, whenever you reach this point, do not go past it. Otherwise you will break. Not necessarily break Maya. It just means that the character won't look natural. So we're essentially providing those limitations to give the animator more freedom within that. You don't want to set your limits too high or too low that they can either not reach the pose, or too low in the sense that they can essentially do whatever they want and break it. You also allow the animator kind of free roaming to express as much as they can. And if you set too much of a limitation on any controller or any body part, they're going to get frustrated not being able to pull that body part just that little bit extra to give it more flexibility or bend and so on. So those are the three primary things that we need to essentially address. So let's quickly jump back to Maya and see how we do that. So inside of Maya, we have different objects. Each of these have their own pivots, as we all know that any geometry that you make have its own pivots, because geometry or any node type geometry has both a shape and a transform. The transform allows us to move, rotate, scale. The actual shape itself could be anything. We control that by modeling, extruding, insert edge loop, and so on. So in this case, if I were to select one of these objects, like this grabbing thing, don't know what it is, it's something. If we were to look at that and then go to its transform tool, we can see that it rotates from a certain point in space. And that's going to allow us to do certain things. We can move it from that point, we can rotate it from that point, we can rotate it in multiple different directions, and some might be useful, some won't at all. So we have to essentially provide those flexibilities or certain limitations to not go and break the reef. So the first thing that I want to do is I want to process each geometry piece by making sure their pivots are in the correct place. That way, when we're going to parent them together, we know how they're going to rotate. And when we rotate one, the other one will follow along. So the first thing that I'm going to do, like I said, is I'm going to jump to my side view or my front view. I'm going to make sure that each of these objects have their pivots along a place where they should be bending. So the first one is going to be there, the second one is there. Some of these pivots might be off, and I specifically place them off away from the center or the place where they're supposed to be rotating from, so that you guys can go and manually place them there. So I'm going to give you guys a few moments to move that. Just before I give you the time to move it, if you're not familiar with moving pivots, if you hold down D, you essentially go to pivot mode, and then while you're holding it down, you're going to use your regular standard transform manipulator to then adjust its position to where you want it to rotate from. If I were to rotate it from its current position, you can see it's just free forming and it's breaking in all directions. If I were to go to, let's say, one of my front views or side view, I'm going to make sure I move it right to that center point, more or less over there. And if you look even closer, you'll notice that this guy is definitely off in the side and in the up-down axes. I'm going to make sure it's right in that center point, and then from this view, that's more or less in the center axis. It doesn't have to be on the side. You want to try and place it more along the center of that object. So now if we were to rotate this, we can see that this is now staying in place along that pivotal axis. So I'm going to give you guys a few moments to do that. A nice little neat trick that you guys can do in terms of pivot placement is if I were to grab this object, I'm going to randomly move the pivot off to somewhere in space. If I wanted to get that pivot exactly in the center of where that vertex would kind of converge into that single point, it's actually quite simple. You go into your pivot mode, so you essentially hold down D, and then together with that you can also hold down any of your magnet snaps. So there's a grid snap, there's a curve snap, and a point snap. So technically, if I were to toggle on point snap, you can see the circle in the center of your manipulator changes from a cube to circle. So now it means it's going to snap the pivot tool into whichever vertex you're going to hover over. So if I click and drag this, it will move to the closest vertex, and then as I move this along that yellow line or the yellow axis, you can then move your mouse to just over that specific point, and it will physically snap just that single pivot axis or the axis that you have selected to that line. And you can essentially repeat that same process going down as well. So I'm going to hold down D, and this time, instead of having this button on, I'm going to talk about the shortcut for it. So D plus V toggles that same thing on, and you can drag it down to where you want to snap it, and that will make sure it's 100% perfectly aligned to that vertex. Okay, so now that we have all the pivots placed where we want them to be, we can now go to the second phase, and that is essentially parenting each object to their corresponding parent. So think of it this way. I'm going to go back to the Photoshop document and just write it here. Let's take the blue object, being this one, and let's call that the child, and then the red one we'll call that the parent. Okay. There's always some sort of parent-child relationship. In terms of setting this up, we're going to use a set of key combinations to parent these objects together, and that's actually not too difficult. It's just a matter of selecting the child first, and then the parent second, and then hitting P on the keyboard, and that will parent these guys together. Wherever the parent goes, the child has to follow along. So let's check what that does in Maya. I'm going to go to this object. I'm going to have that one selected, and then if we look at this object in 3D space, let's quickly do that. We can see that these are two different objects, and I don't consider this one to be a parent or this one to be a child. These are kind of on the same hierarchical level as, they're the same object. They're doing the same purpose of clamping something down or holding something down. So I would technically consider both these as children, and then having this one to be then the parent. Definitely not of the same species, but right. Yeah, exactly. So I'm going to grab this one, and I'm going to shift select the parent object. Okay, and that essentially added to the selection. You have to add it, otherwise you're replacing it. Once you have those two selected, I'm going to hit P, and that parents the child to the parent object. Now, just to confirm that, I'm going to open up the outliner and show you guys what this looks like. Obviously, bad naming conventions. Please don't ever have your outliner look like that. But if you were to look at these two as they are right now, if I were to parent this one being cube 6 to this one being polysurface 30, just by hitting P, you'll now see that polysurface 30 has a little plus sign next to it. If I click that to expand it, you can see polycube 6 is now attached to it. So that now there's a direct relationship to the two. If I were to select this one and shift select the parent object again, being polysurface 30, hit P again, you will now see polycube 5 then places itself in exact same hierarchical structure. Thus, if I were to grab this one, being the parent, and I move them, the two children objects will follow along for free. I don't have to move them separately, but if I select the child object independently, I could still move that one independently. Think of it this way. I like to describe it as the parent takes the kids to the park, the kids go run around and they play. As soon as the parent leaves, the child gets back in the car and they go home with them. Okay? Usually that's how it works. So you're going to use the same kind of concept here. The children essentially have free roaming to do whatever they want, but as soon as the parent says, hey, let's go home, they go home together, even though the child has stayed or offsets itself from the position of where it used to be. Right, I'm just going to quickly reset position. So using this theory, we're going to now take each of these objects and parent them according to that hierarchy. So let's say this is now the parent object. The next one up will be its parent. Essentially, you're going to create a massive family hierarchy using this method where you essentially go back in time. You're making the last one in the list being the oldest grandparent. Yeah, exactly. So if I were to select this one, shift select that one at the top, and hit P, and now if I select that one at the top, all three of those sets will now follow along. So I'm going to repeat that same process, and then I'll get back to you. one extra thing that I would like to talk about is once you go through this and you've parented them all as you would expect them to be parented, and you select them and you see that at some point that there's one that you have selected but it doesn't actually highlight all the others, that somehow tells me that my method of parenting, or in which order I've selected them, might have been incorrect. I could have made this one the child and this one the parent, or I might have had a different one as the parent object. So if that's the case, you need to go back to the one that's causing the problem in the first place. Like for instance, if I have this one selected, everything else goes down the list. But this one in particular that's in between these two, they're kind of separate from that. So I essentially need to find the one that's causing the major problem and then unparent it. The way I do that is I essentially go to the main object, being this polycylinder 8. I'm going to hold down Shift and then click on the little plus, and that will literally expand the whole hierarchy list for me so I can see all the objects as they are parented to each other. From that, I can then go through the list and I can see what I technically want is this perfect continuous stair-stepping. And somewhere along the line, I have missed it. I can see right there is one that kind of goes straight down and then keeps going through that path. So right there, that tells me this object is parented to the wrong parent in the list. So I'm going to have that one selected, and that's this one. I'm going to hold down Shift and then press P, and that will unparent those two objects from each other. So once I have that unparented, I can then go and reselect the child object, Shift select the parent object, and then press P, and that will reparent these into the right hierarchy so that they continuously flow through the list. The only two that you would expect for this particular model to have them stacked right next to each other would be right at the end, these two over here, because there's two of them and they're the two children that's parented to this one at the top. So I just wanted to add that as an addition to kind of help you problem solve any issues that you might have in terms of parenting. Right, now that we have covered the whole parenting setup, we can now go and essentially test it and check if it's working. The only thing that obviously won't work is the limitations, because we haven't set those yet. So if we were to grab these over here, and then we rotate them, you can actually see those rotating along their own pivots, which is successful. Obviously the one goes in the negative direction and the other one goes in the positive direction. For this one, we can see we need to essentially kind of rotate along that y-axis. So if I click on the y-axis, it's just maintaining its rotation within that internal kind of groove. So with that selected over there, we can see this one rotates over there. This one rotates the whole thing. This arm rotates over here at the top. And you'll see at some point it will actually crush through this. So you'll have to just, when we set up the limitations, essentially just prevent it from going through those parts. Also cannot go past that point, that's like a stopper. So we have to make sure that is set up later. Then this one will essentially pivot from this axis over here, so we can just rotate that around there. Get that to work. This one will lift up the whole arm, going to the side. One over here, same kind of thing, up and down. This one is kind of rotating from the inside, like that. Controlled through a motor inside this piece of geometry over here. That will pivot again from that same axis. This one over here will pivot from the base. And then finally, this one will rotate along its own axis. That allows us to kind of pick something up and move it across to another area. And then the last piece of geometry is just a base that we can move to place, let's say, multiple duplicates of these guys. So we have multiple arms. And the nice thing is, if you have parented everything with the pivots and everything placed, you would essentially duplicate that with all set up. No need to go and manually set it up afterwards. Right, so we need to essentially go through the limitations process first. So let's quickly have a look. Some of these pieces of geometry have history attached to them, or they might even have like your typical channel information: transform, rotate, and scale. This would be a major issue if we had to leave it there, because if we had to maybe rotate the object in a certain limitation and we have information in the channel box, that might prevent the object to go back to the default state. Not necessarily prevent it to go to the default state, but rather the default state would be with these values, and that would be very difficult to remember them unless we actually write down per piece of geometry exactly the initial rotation, transformation, and so on. So before we get into the limitations, you always want to make sure that the mesh is actually freeze transformed, and that will prevent any of this information to pass into the next phase. So let's quickly have a look. You can grab all your mesh all at once, and then you can go to modify and then freeze transform, and that will make sure every piece of geometry has their channels cleaned up and cleared up. You can also additionally select all your mesh and then go to edit, delete by type, and then history. Shortcut for that would be Shift, Alt, and D. That will clear the history, and that will essentially prepare the mesh to go to the proper rigging phase. I'm going to give you guys some time to do that. Great, so now that we have done all those steps, we can now go into the attribute editor, and then we can go to the set limitations controls that you will find under the transform node. So each object, and this is something that I want to make very clear to everyone so that we are aware of what we are trying to do. In fact, 1 second. That's more or less the center. There we go. If I were to look at this object and open up a thing called the hypergraph, I think it's hypergraph hierarchy. There we go. And if we look at these, in fact, let me try the other one. There we go, that's what I want. Right, so if we look at the hypergraph hierarchy, this is probably the scariest thing that you've ever seen in your life. This is like a black empty canvas with random nodes attached to each other. They've got these lines that essentially represents the relationship or the connection between them. So if we have a look here, that mesh that we have selected over there will show up in the hypergraph. If I graph it quickly, I'll click on that, and that mesh is called Polycube 6, right? So this mesh comprises of two parts. This one itself that has no shape name attached to it, the one that's highlighted, that one is literally the node that we control over here in the channel box. So if I type in a value of translate X, this information is fed through this node that then goes and tells the shape to move in 3D space. Okay, so this one itself is actually the mesh that we see. So we can essentially do extrudes and bevels and all those fancy stuff. And then as the history progresses, this node becomes more and more advanced. It has more input connections, providing more information to how the shape should essentially change. So knowing that there's two nodes connected to the same thing is very crucial to understand what we're doing here. I'm going to close this window, and I'm going to go to the attribute editor, and you'll see that this mesh over here, when I select it, has exactly the same two sets of tabs. We have the P-Cube 6 and the P-Cube Shape 6. The P-Cube 6 is the transform node. Even if you look all the way at the top, it says transform, and then the name P-Cube 6. And then inside of that, you'll see the transform attributes, things like your typical translate, your rotate, and your scale. So this node is the one that's going to be controlling the limitations. So that's where you would go and look for it. If you're on the shape node, you will not find the same attributes. So under the P-Cube 6, we'll see there's a limitation information. So I'm going to open that up. and you'll see that there is a set of essentially 3 different drop-down menus. Each of those have their own limitation controls. We're primarily looking towards just the rotation. We're going to ignore the translate for now. I will show you guys a different way of approaching that. So just expand the rotate, and then in here we have essentially 3 sets of columns. Okay? For each axis, obviously, you have limit x, limit y, and limit z. You've got a current value for what the current value of that particular object is rotated to or at. You have a minimum value to how far it can go in the negative direction, and a maximum value to how far it can go in the positive direction. So all you have to do is you have to go and rotate your object before you toggle any of these buttons on, and rotate it up to the point where you think that object should go as a maximum / minimum value. So just rotating this one up, we can see that the value for it is currently at 53.9. I'm going to round it off to 50 degrees. Okay, that's the furthest that I want this object to go at. Then I'm going to copy that value. I'm going to type this as a value of 0, and then open up the min and max. So this was a positive value, right? It's a value that was in the positive direction, thus we have to put it in the max side. If you were to put it in the min side, it will automatically force the object to go into that direction. Okay, so we're going to go to the 45, type in 50 to override it, and now if we were to move this handle up, you can actually see it only goes up to 50. Even if I try to pull it further than that, it will only go up to that maximum value. Same thing goes to the negative direction. So if we go through to the other side, you can see it crushes through it. That's not what we want. So the default value at 0 is the default value that that object should go at for the negative direction as well. So I'm just going to set that up over there to 0, and then when we try to go into that direction, it will literally stop. It will not go further. So I'm going to essentially repeat that same process for all the objects. Some of these objects will have full 180-degree rotations, like this one for instance, and you can see this one rotates along the y-axis. So when you start rotating it, just immediately look at which one of these channels essentially receive information, and then change their rotation y minimum and maximum value accordingly. Right, I'm going to give you guys some time to do that. So continuing from where we left off, once you have this set up, everything is kind of, with their own limits, and they're kind of working together as units, it's probably a good time to then, give it a test. We'll rotate things around, see if they actually do what they're supposed to do. In some areas you can definitely see like this thing shouldn't be rotating along that axis, so that's obviously broken. Now what you could do is you could set the limits for all the other axes that you're actually not using to all 0, and just pass the values over, just by clicking on these little arrow buttons, and then toggle on the limits so that now they cannot rotate in the wrong direction, but only the one with the actual values would then work. So you could do that. That's one way of doing it. The other way would be to actually go to your channel box, and let me quickly reset my values for the Translate Z before I do anything. I want to make sure that all channels that we are not going to use, or how the animator would be controlling this, they probably won't be scaling it. They would probably not be toggling on visibility, nor would they actually move the individual components around. It has to rotate together to kind of stay as one unit. So in that case, you're essentially taking away anything that the animator would not be using, and that could potentially break the rig. So for that, I'm going to go through each of these again. I'm going to select the channels that I'm not going to use, and you have to be very sure, like this one only uses the z-axis. I'm going to select all the translates, and then rotate X and rotate Y, and then I'm going to hold down Control, click and drag over Scale and Visibility, and that essentially isolates only the rotate Z that we're essentially going to be using. So with those selected, we can right click in here and then go straight down to lock and hide selected. And that will take away any of the attributes that the animator should not be fooling around with. So then you'll have to run through the process of doing this to all the parts. I'm going to give you guys a few minutes. Let's say by accident you select something and you did not want to have that one go and lock and hide itself. Let's say by accident I select all these and I go lock and hide. How do you get back to that window? There's two ways of approaching it. I'm going to show you guys the easiest way. All you have to do is go to the actual channel box tabs here at the top, or the name drop-down menus, and you've got to find the thing called channel control. So under edit, channel control, you're going to click on that and it brings up this window. So this window has a keyable tab and a locked tab. So before you can get to the keyables, you have to essentially unlock those. So I'm going to click and drag over these, and with those selected, I'm just going to move them back to the non-locked side, and then on this side we can then go and choose the ones that we actually want to bring back for visibility's sake. So keyable means also visibility, so I'm going to look for rotate. You can see there's a lot more other attributes that you typically don't use on a general basis. So translate X, rotate XYZ, and then, scale XYZ and rotate XYZ. I'm going to move these back to the keyable side, and that will then bring them back so that you can go and change them accordingly. Now that we have all the limits set up, we can now essentially pick just the attribute that we want to animate, and then you can see that if we go to the, for instance, the translate tool is primarily kind of grayed out, so it's essentially meaning that you cannot manipulate along the translates. If you go to the rotational tool, and if we have a look here, we'll see if we try to rotate along the x-axis or the y-axis, it's not moving at all. It's completely locked. The only attribute that is accessible is this one, and this one is still constrained to a certain degree of rotation as well. So that's quite nice. So all you have to do is select the mesh, click on the attribute that you want to animate, and then middle mouse click and drag in the viewport. That will give you an interactive slider to change the position of that object. So that's quite nice. And each of these objects now have their own limitations, and you can even select multiples for the same attribute and rotate them if you wanted to. You can see this one, and this one all rotates along the rotate z-axis. This one, on the other hand, like I said, rotates on a different axis, has its rotate along the x, so that's quite nice. You can rotate that around there. And the only problem is now it's quite difficult for the animator to control this object. If you had to go and manually, pick the object and click on the rotation or grab the handle, it's not too tedious, but it's still more tedious than I would like it to be. So the last step in the process would be just an addition to this one. It's going to be a number 4, step 4. And the step 4 is essentially create, control, and then we'll call this one global. Okay, global control, and this one will essentially provide all the attributes in one list for all the objects, so that you don't have to physically select the mesh that you want to essentially move or rotate. So how this works is we're going to create some sort of a shape. It could be a regular circle, it could be a custom shape that you design yourself, it could even be another object for that matter. It doesn't really matter what you use as a controller, but for the simplicity's sake we typically use a curve, because a curve is something that's non-renderable. So if you have a piece of geometry that represents a controller, that piece of geometry would be a random cube that's floating in the scene, and then if you render, you've got this cube that's always in your view. So you typically try to use a curve or some sort of a curve-based controller system instead of physical geometry that is renderable. I mean, there is some overrides that we can toggle on and off in terms of like render settings to say whenever the scene renders, that particular object should not be visible or renderable. Okay, so there are some controls for that as well. So that's essentially going to be like the next step in finishing up this control system or the rig. So each arm, each controller that moves around with clamps and all those things, these have custom attributes, so or rather attributes like rotate X, Y, and Z in some cases, and these will all propagate to a controller, let's say a little arrow. It's pointing in different directions, saying this guy will control the position, rotation, and all those kind of things. Right, so let's quickly have a look how we can build this inside of Maya. It's a bit of a process to set up, but it's not necessarily a difficult process, but it takes some time because you have to open up an additional connection editor window that will then set up the relationships between these attributes for that particular controller. So let's quickly have a look. I'm going to go back to Maya and I'm going to create a new object, and that object will be a curve type. Now you can use a circle, that's probably the simplest object in the scene. It has the least amount of points. Not that the points or any of that really makes a difference. So there's my curve, and this curve is going to be our controller that's doing most of the work for us. So you can then decide if you want to edit the shape of the curve. You can go to its component by right-clicking, Control Vertex, and then choosing certain points, and then maybe you want to scale them out to give it more of a custom shape like that, or pull this in to create more of an arrow shape. You can add additional points to it to really customize it to your liking. In many situations, especially for human characters or bipeds, you design the controller to look like the body part that is meant to control in the first place. So you just either use your curve tool over here, EP curve, and you can draw out a custom shape, say that's something, a clamp of sorts, and then you can use that to do whatever you want. So in this case, I'm using a simple circle, tweaking some of the points if I needed to. You don't necessarily have to. And then you will be renaming this accordingly. So let's quickly call this global. This is going to be more of a global rotate, and not necessarily, position. Maybe if you want to move this object over here for positioning, we could do that. So you would have to then make sure that this global controller has a custom attribute that allows the rig or the arm or the whole thing to move left and right or up and down and so on and so forth. So for the most part, this custom controller will not be using its default attributes like the translate, rotate, and scale. We're essentially going to clear that out and build our own custom set of attributes. So in other words, we can right click and say lock and hide completely. We don't need any of that. And then we can build our custom attributes. So same place, edit, and then add attribute. This will bring up this window, and then we can change the name. Let's say clamp for these. And then we'll call that under clamp left. Let's make it left. You can choose, make it nice names. Something that's recognizable. Clamp left or front, back, doesn't matter. And then we have to choose the type of attribute that this will be, whether it's an integer, a float, a vector type, or so on and so forth. For the sake of what we wanted to use it for, we essentially wanted to use as a float. Now what is a float? It's not the thing that you drink, It's not a Coke float or a cream soda float. It's essentially decimal numbers. So it's not solid numbers like 1, 2, 3. It's like 1.358 or 10,000.20 or something like that. So it's just a decimal type of value. And the reason why we're using that, you have more smaller incremental values so you can control the position. If you use an integer, it's more of like a snapping kind of thing. It goes either to 1, 2, 3, and any small rotational values in between that is essentially lost. So we're trying to not use an integer type. Okay, and then we essentially choose the maximum value and the minimum value. You can choose whether you want to set this to, whichever maximum and minimum value. These could be exactly the same as the maximum value that we have already set for these objects. So for instance, this clamp, the one on the front, has a minimum value of minus 45 and a maximum value of 45. So I can easily go and type in 45 and then, minus 45 and then maximum 45 with a default of 0. So when I add that attribute, when I close this, obviously you have to select the object, otherwise I deselected that by accident. I have to type it in again. Clamp, let's call this clamp front, and then type in the values, minus 45, 45, and the default of 0. So as soon as I add the attributes, you'll now see that it has an attribute in the channel box called clamp front, and this one has a maximum value of minus 45 or minimum value of minus 45 and a maximum of 45. So you'll have to do this for each of those objects with their own specific values. Now you don't have to call that, let's say left arm, inner, outer, whatever, and then say rotate X. Just call it rot. To know there's only one attribute within that object that is keyable or animatable. So you don't have to go and set that to a very arbitrary random name that doesn't make sense. So just choose something let's for instance close this and take, it will probably be an easier way if we name these according to their set of sequences. So if you say base 01, 02, 03, 04, 05, and then when you name these attributes, you're going to easily know which one is the base at the top or at the bottom, and then going more towards the end of your control arm. So I'm going to give you guys a few minutes to go and set up these attributes. Now that we have all the attributes assigned, we can now go in, and what I've done is essentially just created the names, but I haven't associated any minimum and maximum values. So what we can do here is, if we wanted to go back and set up very specific limitations for each of these attributes, all you have to do is select the attribute that you want to edit, go under edit, and then choose edit attribute, and then choose choose the one that you want to edit, and then choose it has minimum and has maximum, and then type in the min and max values. So you could go and do it after the fact as well. But typically when I create these attributes, I start off at the base and I work my way down, because unfortunately you can't rearrange these, let's say arm 5 was underneath arm 6, you can't go and reorganize them. You have to unfortunately delete everything below that and then recreate them again, which kind of sucks. Right, so now that we have all those, we essentially now need to link the attributes for each of these custom channels to each of these objects' rotations, whether it's rotate X, rotate Y, or rotate Z. Now to do this, we're making use of two different tools. Primarily you can use just the one, utilize the connection editor, which you will find typically under the window, and then I think it's general editors, and then there should be a connection editor right there. So once I open this window gives us left side and right side as outputs and inputs, or you can just reverse the front or from to by clicking that, and now it puts the outputs on this side and the inputs on that side. So it just depends on how you want to work, but the default is always from this side to that side. So making sure that this button and arrow points going to the right. So how this works is we select the controller and we load that in on the left hand side, because this one has all the output information that needs to connect to the inputs on the controllers, or rather the actual geometry objects. So I'm going to click on that, reload it, and you can see global rots, and then if we scroll down all the way at the bottom we have base 1, base 2, arm, and clamp. Right. So with those, we're just going to select the first attribute that we want to link to something, and then, in fact, let's do just one of the arms for now. take that one, and then we're going to choose, let's say, the corresponding arm in the outliner. Select that guy, and we're going to say reload on right, and that loads all the attributes related to that. So we need to essentially control the rotate Z, so we're looking for that attribute in this list. So if we go and look here, we can see that one is grayed out. We just need to click on the little plus and then choose rotate Z, and that will link arm1 attribute to rotate Z attribute. So once that is linked, you will see that the geometry, with the geometry selected, that particular channel turns yellow, meaning there's an input connections that's driving that particular object. Thus, if I were to just kind of move this off to the side and quickly grab my controller, if I were to grab arm and middle mouse click and drag, I can now see that I'm literally controlling that particular attribute from that point, which is excellent. It really makes the process a lot easier. And if I type in 0, it just goes back to the default position. The nice thing is we can then, if we were to animate this, we can just quickly toggle this on. We can see the timeline. I'm going to talk about the animation in the next class. But for now, just to quickly show you guys what I'm talking about, I'm going to right click on this guy, key select, go a few frames further, grab this attribute and rotate it backwards. For that keyframe over there, key select, we can now see this arm will go backwards and forwards along that axis. I'm going to get rid of my animation, we don't need that at this point. And say break connections, and then 0 that out. Right, so we essentially need to go through each of these objects and just link their actual connections from the custom attribute, being the arm, to the rotate, whether it's rotate X, Y, or Z, the one that's specifically set to that custom object. Okay, I'm going to give you guys some time to do that. Right, so that's more or less the setup. So once you have linked all these attributes to each of these controllers, you should now not be able to mess your rig up. You don't have to physically select the meshes anymore, because each of these attributes on their selected geometries should have a yellow connection to them, except for the base. So all the others should have a connection. Thus, I can then select my main controller, my global rotation controller, and then select the attribute that I want to control and just rotate those accordingly. Now, if you haven't set the limits of your actual custom attributes, this would probably be a good time to go and do that. For instance, if I select the clamp arms, you can see this one goes up to the maximum value, but also goes through the other side. So you have to go and edit it so that they do have limits, like we did in the previous step where we set the limitations on the geometry. So now I'm going to leave it like that. That's more or less what I wanted to cover in terms of the kind of hard surface rigging kind of mechanical setup. It's very simple. You just use controller pivots, you use your geometry pivots, you use your actual parenting setup, and you set limitations and additionally add controllers to drive all of that. So typically the animator would only be able to select this attribute and then do all his tweaks according to the mesh. So the last little step that I want to do, I want to essentially have my mesh non-selectable. So I'm going to grab that and I'm going to put that in layer, and then we can put this layer to reference, thus the animator cannot go and select it by accident. So we just call this geometry to, let's say, mechanical arm geo, and then in brackets, do not touch. Okay, so that they know, the animator should know, whether it's you or anyone else, that they should not be fooling around with that. So I think it doesn't like the space. We have to make sure that we don't add any spaces between the words. So let's see, character name. Okay, it doesn't like the parentheses. I need to take that out as well. There we go. Save, and we should be good. Right. So now the only thing that's selectable in the scene is going to be our global controller with all the custom attributes, and I would say this color is definitely not as easily recognizable. Also, this controller is quite small, so you can go and change the components on it by going to control vertex, select all of that, and then scale it up. So you might even want to place this right behind or right underneath the main arm so that the animator can select it there. And then lastly, I'm going to change the color of the shape, and that's quite simple. All we have to do is go to the attribute editor, and then under the transform node, being the global rot transform, we're going to go to display, and then we're going to turn on the drawing overrides. You have to check the enable button, and then where it says this index, we can actually go and change that to whichever color we like this nice bright red. And that will be much easier for the animator to know, oh, that's the thing I need to select when I need to, manipulate my mechanical arm. So I can then select that, select the attributes, and you can select multiple attributes for that matter if you needed to kind of rotate things accordingly and move things around. And then lastly, if you want to get it back to default, you type in 0 and it resets it back to where it's supposed to be. Right, so that's more or less what I want to cover in terms of this. The next part is essentially organic rigging, and that entails setting up bones and connecting bones to the character, and then skinning those bones to the physical geometry so that it's more of an organic bend instead of hard surface kind of rotations and so on. So what I'm going to do now is I'm going to open up another file. I'm going to save this one and then just call this one my final or end result. Or rather, shall we call it working rig, so we know it's working. Right, so I'm going to do file open, and then I want you guys to open for me the skinning arm underscore start. Right, so in this file we have just a simple character arm, nothing too special, and it's also not the greatest in my opinion. So what we have is essentially just a piece of geometry and then these random lines going through it. So these are actual bones, and the reason why they're simple lines is because the scale of the actual display of these handles for the bones are very, very small. So in fact, we're going to start from scratch anyways. So what I want you guys to do for me is, if you look in the outliner, you'll see that there's joint 1. If you have that selected, you can press delete, and that's going to get rid of all the unnecessary bones. Now that we have deleted those bones, let's quickly talk about it and let's get an understanding of what it's all about, and then we can continue setting up the rest of the skeleton rig and so on. So to access the rigging system inside of Maya, there's a few tabs that we can work with, but primarily you typically want to go to the drop-down menu for the different sub-menu sets. You want to set this to rigging. So that's the first thing I usually do. That's just preparing the menus at the top so that we have all the tools that's specifically associated to the rigging. Right, so the first tab that we're going to address is going to be the skeleton tab. And this is where we create joints, we insert joints, we can change the orientation of the joints, we can make additional connections, and we set up IK handles and so on and so forth. So let's quickly have a look at the first one, and this is the one you will be using for the most part. So by clicking on that, it gives you the manipulator to place your bones. So I'm just going to click in my scene, and then I'm having some issues with the display of the bones. Just before we go any further, I need to address that. And I think that's to do with the scale of my default joints under display options. So let me quickly have a look. If we go to the animation and then joint size, we should be able to have this joint size scaler, and we can change the physical scale of the bones. I'm going to click on that. It's still having some issues in terms of display. Can't figure out exactly what that is. I think it is to do with our viewports. That definitely looks like a viewport bug, so I'm going to switch from regular viewport 2 to legacy viewports. And yeah, that's exactly what the problem is. I think it's a My 2015/16 bug. So as soon as you switch your render view to legacy, you can see it just puts it back to where it's supposed to be. Right, so that's more or less what I was kind of expecting when I created the bones. So let's start again. I go to create joints, and then when I place my first joint in the scene, a very, very tiny little sphere. I'm going to frame on it so you guys can actually see by hitting F. So that's a circle, and it has essentially your typical manipulator transform arrows, Y, X, and Z. And by default, this joint is parented to the world, meaning its rotational axis is exactly the same direction as the world. As soon as I introduce a second joint, Maya will then generate a bone in between those two joints, being this little triangulated shape that's kind of pointing towards this one at the end. And once you do that, this one that we placed first will automatically reorient itself to now aim to the direction of the second one that we've placed. Now what's nice about this is if you were to place multiple joints like arms and legs and so on, and kind of match based off of your reference or your actual, let's say, profile views or front views from your character, it automatically redirects the joints so that they know in which direction they should be bending. Thus, it automatically sets its initial orientation. If you were to just place single joints and then afterwards parent them together, you're essentially making it much more harder for you to go and set the initial orientations, because you have to do them after the fact. So you can either work with them as independent joints. For instance, if I just want that single joint, I can click and press enter, and that will now have just a single joint that I can move around and parent objects to, or skin to a piece of geometry if I want. But you could also click multiple joints, and as soon as I click the next one, you'll see that the first one that I placed will automatically reorient itself. If you have a look there, it changes the direction accordingly. You can see right there. So, and also if you hit backspace, you can essentially go back to where you were previously and just replace that joint to kind of make sure that the orientations are where you want them to be. If you're completely done and you're happy with your placement of the joints, all you have to do is press enter, and that will initiate the final creation of the bones, and that will essentially be your skeleton, and that you can do multiple things to. Why skeleton? Why do it this way instead of the previous way where you just parent objects together and manually place the pivots? Well, just think about it. These are essentially your pivots. They go exactly where you tell it to be, and it automatically creates the parent and child connection for you, so I don't have to go and spend the time doing it the old way, being manually placing the pivots and then also parenting these objects accordingly. It's a much easier workflow, and it just works. Right, so looking at our character, or rather just the arm of the character, what we want to do is we essentially want to place the joints from something like the top view, to kind of get that angle of the elbow and then going towards the wrist. And then we might have, let's say, another joint going into the hand more or less to about there. So let's quickly see how we can do that. The first thing that I'm going to do is I'm going to jump to my top view, kind of zoom into that, and I'm going to go to my skeleton, create joins, and then what I want to additionally do is turn on an option inside my viewports that allows us to show the skeleton as an X-ray mode. So to do that, we have to go to these buttons here at the top and find the one that says X-ray joint. This one is very close to the exposure button, this green button over here. So it's going to be the one just next to it. So I'm going to click on that, and that essentially allows us to view the skeleton in X-ray mode. So by placing my first joints, and again, just be very careful that this viewport in the top view is again set to viewport 2, so you have to set this per channel, or per viewport. Just make sure you say legacy viewport for that one as well. And now you can see what I was referring to. So now you can see the bone right through the actual skin. I'm going to place the first one more or less where the shoulder would be, and I can hold down the middle mouse button and move that even after I have physically placed it to kind of get it to where I want. And then I'm going to place my second one where the elbow should be, and then the third one more or less where the wrist should be. And then finally I'm going to hold down shift this time and then go click and drag, and that goes in a perfect straight line even if I move my mouse off to the side. So it essentially constrains it in a perfect straight line. So once I have it more or less where the fingers would be, I will then press enter, and that's going to create my arm skeleton. I'm going to give you guys a quick moment to do that. Now that we have placed the joints, you will notice as soon as we go to, for instance, our perspective, we might think that the joint is in the model, but it's not. So the reason for that is because joints are typical objects that actually snap to your grid. They don't snap to geometry unless you actually hold down V for vertex snapping, and then you can essentially kind of place them along the geometry. But it's actually better to do it on a flat plane and then move it back into position where it's meant to be. Right, so that brings it to the point, don't create joints in a perspective, because you can think that, yeah, I'm going to place one there. Let's go skeleton, create joint, one for the elbow, one for the wrist, and one for the hand. And when you see, it's not there. So just be very careful whenever you work. Rather jump to your orthographic views, fix it there, and you should be good. Now that we have done this, I'm going to grab just my base joint, or joint 1, and you'll see as I select these are essentially named sequentially 1, 2, 3, and 4. And you also want to kind of keep that naming convention throughout most of your work. Whenever you create a joint chain, let's say your skeleton, let's say your leg, or let's say your vertebrae in your spine, you typically want to call it, let's say, bone 1, bone 2, bone 3, or NM1, NM2, NM3, or whichever. Just keep that constant name throughout your actual rig. I'm going to select my joint. I'm going to go back to my front view, and I'm going to move this straight up. Again, my viewport is bugging out. I'm going to switch to legacy. Let's bring this up into position. And the first thing that I want to point out is you should never rotate these joints manually using these rotational controllers. You should rather tweak your joint orients, and I'll address where you would do that. But before we do that, just kind of get the position of the elbow more or less, or rather the shoulder more or less where we want. So let's say around about there. Around about there should be good. Now you can see that my shoulder, my elbow, those two are quite nicely aligned, but then my wrist is kind of off. So what I want to do instead is I want to rotate just the end joint, or being the base one, so that the wrist itself is more or less in position where it's supposed to be. So to do that, I'm going to go to my attribute editor, and then in the attribute editor, you'll find there's only one tab at the top, and it provides you all the information you need. So there's essentially these 3 channels over here that's called joint orient, X, Y, and Z. So what I want to do is I want to get the orient axis that allows the whole arm to essentially rotate down, so that the pivot of the wrist is more or less where it's supposed to be. So how do we do that? Essentially, if you hold down Control and you click in one of these boxes and you drag to the left or to the right, it gives you a little interactive slider. not middle mouse click, but left click and drag, and that's going to give us the controller to rotate X, Y, and Z. I'm going to undo that and choose the other one. No, that's not the one. Choose Z. Yes, that's the one. So I'm going to rotate that until I have the wrist aimed in the right direction, and now I can see my elbow is slightly off. So I'm going to move this up a little bit more so that one is more or less in the center, and give it a tiny bit of extra rotation so that we have a perfect straight line going from shoulder to elbow to wrist. And then lastly, this one over here, we will manually control by grabbing our wrist control, or rather wrist joint, and rotate that one down a tiny bit to kind of aim in the same direction as the hand. Typically, it would be better to physically make your geometry perfectly straight so that the rigging process is easier. It's easier to fix geometry position than joint position. So rather, when you create your own characters, make sure that the geometry is nice and straight. You don't have too many kind of angles that's bending in different directions. Right, I'm going to give you guys a few moments to do that. Now that we have placed and changed the orientation of these joints, we're going to do one more thing. We need to make sure that these joints are obviously aiming in the right direction from all axes, not just from one view. So just go to all your views, especially perspective, and you want to make sure that the actual bones are not sticking out or anything. Like that would be a good place more or less where the joint should be. And a lot of times you actually want to place the joints a little bit closer to the edge of the surface instead of perfectly in the center of the cylindrical volume, if you will. The reason for that is because it allows it to bend more into one direction than away from the other, but that's anatomically just something that you might have to consider. Different body parts will rotate at different angles, and that's something that you have to go and study. So the next thing that I want to do is I want to essentially now take these bones, and if I'm 100% happy with their placement, I would then go and actually skin it. Now, before we go and skin it, I also want to show you guys how you can add additional bones even after you have created the actual initial set of bones or joints. So to do this, we have the insert joint option, and we also have a mirror joint option. So let's say you want to have the other side of the character to be created as well. You can actually select the joint that you want to mirror, and it mirrors it over to the other side. So that's where you would use this feature. So for now, what I'm going to do is I'm going to go and insert joint. And then how this works, it says insert a joint, click and drag on the joint where you want to insert it. So I'm going to click on the joint and drag, and you can see it follows that perfect line. Even if I go to the sides, it keeps following that path along that center axis. So that's great for if you want to just kind of divide the mesh, or rather the bones up even more. Like for instance in the character's tail, you would place one at the base, one at the tip, and you can kind of space them out more or less evenly. So that's a nice feature. But what I want to do is I want to add additional joints for maybe the fingers. So how I would go about it is more or less the same approach as we did initially with the creation of these joints. I'm going to go to skeleton, create joint, and then I'm going to place my first one where I want the knuckle of my index finger to be. So once I have that placed, I'm going to place the second one in a straight line, third one in a straight line, and then the fourth one in a straight line, more or less evenly spaced out. Right, so I did not place them exactly where the joins on the mesh would be. I tried to kind of keep that perfect straight line going through that. Why? Because the hand is rotated slightly downwards. So once I have entered and created the joints, I'm going to take my joints that's now lying on the ground. We have to move that back up. Line it up more or less where I want it to be. That first joint. And then what I'm going to do is follow the same process of rotating these until that first knuckle lines up where it's supposed to be. You could still move this if you need to, You can see that's more or less where it's supposed to bend from. And then you can grab the next one, rotate that down, and then the next one, you don't have to move this one, you can actually just keep that one there where it is. I'm slightly off, so some of those joins might be a bit too long, so what I'm going to do is I'm going to select them and then move them along their local axes. Now to do that, I need to go to my actual move tool settings, and I need to change this to objects, and that gives me the rotational axes for this joint, the parent joint, and I can just pull that along that axis, and that makes sure that I don't go and rotate it by accident or break the orientation direction. I'm just following that same path along the axes of the finger. And then lastly, grabbing this one, rotating that down a bit, and then bringing this a little bit more to the tip of the finger. So that would be a really good placement, more or less, for these fingers. This one might be off a tiny bit. You can see there's the bend. This is slightly backwards. So I'll just pull this one more or less into position. Right, I'm going to give you guys a few moments. Right, so now that we have the fingers more or less placed where we want, or rather the knuckles for the joints, we can now go and connect this set of joints to the main hand joints over here. So it's very much the same process as the regular parenting setup. You would select the child, you would shift select the parents, and just hit P, and that connects it for you so that you can use that. You can then go ahead and duplicate that finger and then move it over, and it keeps its parenting connection to all the others, to the main joint. And you can repeat that for all the fingers until you are completely done with, the fingers in the hand. And then again go through the same process of rotating these until they line up with the actual mesh using the joint orientation. So just for the sake of time constraints, what I'm going to do now is jump straight into the actual rigging, or rather the skinning process. I'm going to show you guys that. So what I'm going to do is I'm going to have the main joint selected, the one that's essentially controlling the full skeleton. Typically on a full character with 2 arms, 2 legs, and if they have a tail, all those joints kind of converge to the center of the hips. The hips is usually your main joint. So all your joints should essentially aim up to that single point. So what I'm going to do is I'm going to have the mesh selected and then the actual joints selected, and then we can go to the skinning drop down menu, and we're going to click on bind skin. Now very simple, if we just apply the bind skin, it does a very simplified bind skin, nothing special. We haven't changed any custom attributes. That is not going to give us as much control as if we went to the options. Just for the sake of this, if we were to select that now, let's grab the elbow for instance and rotate the elbow, you can actually see the mesh is now deforming accordingly. Now if you pull obviously the wrong direction, the poor guy will break his arms. Right, if you select the wrist, we can rotate that down, but you can see it's very round. It doesn't give us very obvious transition and sharp lines to where it's supposed to bend. Now what's really happening here? The skinning is essentially applying a weight transfer from the bone position to the closest vertex or set of vertices around itself. So it's kind of like a volume-based area of effect. So the areas, or rather vertices closest to the joint, will get most of the direct transform position or the effect of the weight itself, and then vertices further away from it will start getting less and less until it reaches another joint that maybe is again closer to it. So we can go through the process of actually painting which parts of the model have more weight to one particular joint and which other parts are more weighted to another particular joint. So before we get into that setup over there, I'm going to undo this, and what I'm going to do now, let's undo that, there we go. I'm going to have my joint selected, and my mesh selected, I'm going to go to the same place and this time to the option box. I'm going to run through most of the common settings that you would typically want to play around with. The bind to joint hierarchy. If you have the joint hierarchy selected, it will select essentially from the joint position, whether it's the elbow, the wrist, or so on. All the joints attached to that will then be bound to that mesh. If you select the root of the body, then everything else attached to the root of the body will also be skinned to that mesh. So you can also choose the option to say select joints and only choose certain joints that you maybe want to have part of the main skeleton or other part of the skinning. So those two are probably my two most favorites. It's hardly ever that I use object hierarchy because we're not really associating kind of object hierarchies to a single mesh. There's only one mesh, so why would you want to have multiple objects to be skinned accordingly? So just for the sake of this, we will typically use joint hierarchy. The bind method is a method of how it's going to use an algorithm to kind of calculate that stuff. The default is closest distance, as I said. So it takes a volume, the closest vertex around the joint will essentially get weighted, and that's it. We also have closest to hierarchy. So if the joints were further, let's say, kind of shifted off away from the actual mesh, you have an option to kind of choose closest to hierarchy or not. Then we have heat map and geodesic voxels. Those are more advanced kind of techniques, newer types of algorithms that does a better job at weighting, but they're not 100% production proven in my personal opinion. I've tried them, they're great, but you don't have the typical classic weight painting tools as you would normally have. So for now, we're going to stick to closest distance. If we look at the normalization, these usually just leave it to interactive, and what it does is, what does normalization mean? If you think about normalization, it's like a conversion. So if we have a value between 1 and 1000, we have a very large set of decimal values that we can tweak, or integer values. If I go and normalize it to a smaller set of values like 0 and 10, then I'm essentially compressing 1000 different integer values into a much smaller range. So all this does is actually looks at the values between 0 and 1, and if things, or the values of the weights, essentially expand beyond 1, essentially it clamps it down to that 1 range. So nothing can be more weighted than 100%. You're not going to have a vertex that's weighted, let's say, 200% or 2000%. It just keeps it within a range that is more manageable. So that's essentially what the normalization does. Leave it at interactive, so it will automatically move and take away weights from one vertex and give it to another if needed be, according to the way that you paint it. Okay. Then we have an option for weight distribution, distance, or neighbors. Typically, just leave it to distance. You guys don't need to change too much of that. And then lastly, these two attributes over here is quite important. We have an option to choose how many bones or joints should be directly influenced throughout the length. For instance, this vertex over here is weighted through 5 different bones. So this vertex could essentially be affected by any of these fingers as well. Why? Maybe you don't want to have a smooth blend. Maybe you don't. In that case, you can provide more weight to the shoulder and take away weight from the fingers so that the fingers don't necessarily influence the shoulder. So if you want to kind of limit the amount of joints affecting a certain body part or certain area, you would just drop that to whichever value that you want. If you want more values to be affected, then you can increase that to a higher number. Finally, the drop-off is essentially a way how quick it goes from white to black or black to white. It's that gradient transition for how much it's influencing and suddenly dropping off to nothing. Right, so that's more or less what you want to be concerned about. So with those selected, I'm going to hit apply, and it applies a basic weighting to that. You can see the mesh turns pink or purple, whatever you want to call that. It just means now the actual skin is connected to the bones, and whatever the bones are doing, they're pretty much just bending and deforming accordingly. So I'm going to give you guys a quick moment to set that up. Right, now that we have that connected up, we're going to do the next step, and that's essentially painting the weights. So essentially painting the weights is distributing the weight transfer from one vertex to another, and which joint is essentially affecting that particular part. Now this part, I would say, is both technical but also very artistic, because that you have to physically bend the joints to see how they look, and you have to paint the ways where you don't want them to essentially bend or kind of warp or distort. So how to do this is you select your skin, or your, in this case, the actual geometry. You're going to go to the same skin tab, and you're going to go to the weights, and then say paint skin weights. When you click on the option box, it's going to open up the option box tool settings on the left hand side, and then immediately it puts you into a black and white gradients kind of map. So how this works is you have a list of influence objects, and those are the actual joints. You could additionally actually append physical pieces of geometry that should influence the skin as well. For instance, if you model out a shape of a, let's say take a bowl, and you put it right underneath the character's belly, right? You can actually have that influence it, so when you animate the ball kind of move around, you can animate a jiggle effect for the belly. Or if you want to have, for instance, some sort of a bone-like slide effect, you can create a bone underneath the skin so that when the geometry goes over it, or when that bone moves around, that it keeps that hard, rough kind of profile edge. So you could do that if you wanted to as well. For now, we're just using regular bones and just controlling that to influence the areas. Now, if you look here, the first joint that we have selected is essentially the shoulder. Now, it would have been better if we actually renamed these joints accordingly. So that's obviously one of the steps that we kind of skipped on. So if we have that joint selected, we can then see that that particular joint has an influence going from there all the way to there. If I were to select the joint 2, we can see how much this one is influencing between the elbow and the actual wrist. When we select joint 3, same thing, and so on and so forth. So what we want to do is we want to make the transition between the black and white a lot more controlled and much sharper in certain areas. So how do we do this? You can either select the joints over here, which is quite nice and easy, but you can also right-click on the joint and say select influence. That's another way of quite quickly selecting between those joints. A lot of times when these joints are not named correctly, it's very difficult to know joint 30 is going to be the joint on the nose, or whatever situation it might be. So by right-clicking on the actual joint and choosing select influence, that's a much easier way to quickly cycle between the joints within the hierarchy list. So with this one selected, I'm going to go ahead and make this transition that's kind of half gray more pure white up to that bending angle, and then suddenly drop to black, and that's going to give us a lot more sharper kind of bend. So just before I do that, I'm going to quickly go back to my regular view, select the joints, and then rotate that so we can kind of see what an ugly bend we have, right? So by putting it in a pose, it's easier for us to kind of see what the effect will be. And then when we select the skin and go back to that skinning, paint skin weights, we can then go and scroll down to the bottom section where we choose how we want to paint it. So we have paint mode, we have select mode, and we have paint select mode. The two that you want to usually kind of go between is paint and select, but for the most part you'll be using paint. It's going to make your process a lot easier. Then the operation type, you can just add, you can replace with a solid value, whether it's 0.8 or 0.2 or 0.258 or whatever the case requires. And then if you say smooth, it blends it into a more of a softer gradient. So it's like physically painting in Photoshop. So you have control, especially when you use a tablet, to paint softer gradients or sharper gradients depending on the pressure of your tablets. So I'm going to go and set this to replace, and then if we look at the bottom, we have a value and we have opacity. So opacity is again like your Photoshop opacity, and then the value is the flow, or the final value that you want to kind of reach. So let's say we put this to a value of 1, that's 100% influence, and then if I go over these joints, I'm going to zoom into that area, quite nice. And then we can change the scale of the actual brush, you can see the circle size. If you hold down B for brush, you can click and drag left and right to increase the size of that profile. And then when we paint that in, we can essentially fill that in to not lose volume where those areas are being kind of off-white. And that will really tighten up that crease between those two colors so that they don't lose as much volume as they did previously. So I'm going to paint that in, and I want to try and make sure you paint all the values where they're supposed to be. And as you do that, you can actually see the mesh just pop back into position where it used to be before we did the bend. So something like that is a much sharper bend, more or less what I was kind of expecting. And then if I hold down Shift, I'm essentially switching temporarily to the smooth brush. So by holding down Shift, you can see also my brush says going from R for replace to SM for smooth. And then you can gradually kind of blend these colors together so that it's not such a sharp transition between those colors. By doing that, I'm getting a much nicer transition. And then if I go back out, grab my joint and rotate it, I can see going back from the original position to there, it's a lot better in terms of shape. Right, so I'm going to give you guys some time to try that out. So once we have all the joints painted, in my case I haven't done much, just done this one so far. So I'm going to grab this joint, or rather the skin, and then open up the window so we can go to paint skin weights. Right click on the wrist joint, and you can see this one is very soft, very kind of all over the place. So another way you can actually select those points is by switching to select mode, and then you can select all the points that you want to tweak. For instance, let me just quickly toggle off the visibility for the joints. If I go to show, I can go to joints. That's going to temporarily toggle the visibility off, and then I can do a quick selection over the area that I want to flood, if you will, like all these points. And I'm going to bring back my joint visibility, and what I want to do is fill all the selected joints with a solid white value, so you can do that as well. So with those points selected, I'm going to go to my Paint Skin Weights tool. I'm going to have the right joint selected, go back to my paint mode. It still keeps that vertices selected, and then at the bottom there's an option for fill. So which value do you want to fill it and what operation? I want to replace all the selected points with this value, and I'm going to click flood, and that goes and floods the whole mesh, or at least all the points that we have selected with that value. If you missed some points, you can go afterwards and paint them back. You can go and say select mode, deselect everything, go back to paint, and then manually kind of fill those in and just see. It seems like it's still selected somehow. Usually if you go out of the tool and you go back, Paint Skin Weights options, and we can fill that in right there. Right, so that's a good start, a very quick way of filling in a large area, especially when you're blocking out these major volumes. And let's test it out. Over here I just want to kind of keep that same edge loop running all the way through, to make sure that is nice and clean. And then we can use a bigger brush and hold down Shift to kind of blend these values a little bit more, like that for instance. That's a nice transition. Right, so I'm going to go back to my regular object mode, just by switching out of the tool by either pressing W or Q for selection. I'm going to select that joint and then rotate that joint. And you can see my rotations are currently kind of going in a world axis orientation, and that's because my rotate tool is set to world. So what I want to do is just set it to object so it aims in the direction of the joint. And now if I rotate that, we can see that's a much better transition than what we had previously. You could additionally go and tweak this side. You can see that's collapsing quite a lot, and that's more to do with the weight from the elbow. So I'm going to right click and say paint skin weights. That's another way of doing the same thing as paint skin weights over here, just by right clicking on the mesh. Let's go back again, right click, paint skin weights. And then from there I can right click on the joint and say select joint. And you can see how soft of a blend gradient this is. So what I'm going to do is just fill this in a lot more right up to that edge so that we try and preserve that crease even further. A nice sharp transition. Down here at the bottom, same kind of thing. And if you go too far, you can use a bit of a smooth to make that transition a little bit more even. And then we can also jump to this one, select joint, and paint back if you want to have that those vertices are more specifically to that transition. In my case, I'm just going to leave it as it was, like that. Right, I think in general that's giving us a pretty good bending deformation, and you can definitely see if I rotate this joint, just look at this area over here. There's some points moving around. That tells me that when we did that initial skinning process, the amount of 5 influential joints is passing this joint to influence those vertices as well, which I typically don't want. Not in this case, changing the settings over here. I'm going to leave it as is, but rather control it manually through the paint skin weights. So I'm going to right click, go to paint skin weights, select mode, not paint mode, but select mode, click and drag over all the vertices around that area that you don't want to have affected. And again, I'm going to just temporarily toggle off the joints so that I don't select that by accident. Make my selection, bring back the visibility of the joints, and then I'm going to go to paint mode and put my value to 0 this time and say flood, and that will prevent it to move at all through that selected joint. So if we now go back out of the paint skin weights tool by pressing W, we will now be able to select this joint, rotate it, and you can see there's still a bit of weight maybe from the fingers or from one of the others, probably from the fingers, but there's no weight coming from that particular joint. But since this one is rotating, these are following along, and those are also affecting that particular point. So you essentially have to go through all those joints, making sure that there's no random stray verts being influenced or affected. And then once you have run through all of them, you should have a pretty good or decent skinned character. What's happening after this? Well, same process as what we did with the previous mechanical rig. You would create controllers for each arm or each elbow, each controller, and then those controllers would control the rotations or the positioning and so on. So that's essentially what the next step would be from there. Okay, I think that's covering most of the stuff that I wanted to do.